this is Jo Karen Hudson. This video is on binomial products. Let's start with the definition. A binomial is a polynomial that has two terms. For example, x plus 2 is a binomial. The square of a binomial is a binomial raised to the second power. So we could have x plus 2 squared. Conjugate binomials are pairs of binomials with the same first and last terms where one binomial is a sum and the other one is a difference. One is a plus and one is a minus. One is a sum and one is a difference. This is an example of conjugate pairs, x plus 2 and x minus 2. They're exactly alike except for the sign in the middle. Now there is a formula for squaring binomials, but I don't require my students to memorize that formula because I think it's real easy to remember what squaring a binomial is. Squaring means I'm going to multiply. If I have 5 squared, it means I'm going to multiply 5 times 5. I'm going to multiply a number times itself. 5 times 5 is 25. So if I square x plus 3 squared, that means I'm going to have x plus 3 times x plus 3. No need to memorize a formula here. So now I can use the FOIL method. I'm going to have the first, x times x is x squared, and then I'll have the outside, x times 3 makes plus 3x, and then I'll multiply the inside terms together. 3 times x makes 3x. And then I'll multiply the last terms together. Positive 3 times positive 3 makes positive 9. And then I will have x squared plus 3x, and 3x is 6x plus 9. Squaring a binomial. Example 2. 7x minus 2y squared means that I will multiply 7x minus 2y times itself. 7x minus 2y. So when I multiply the first terms, I'll have 7x times 7x is 49x squared. My outside terms, 7x times negative 2y, would be negative 14xy. My inside terms, negative 2y times 7x, would be negative 14xy. And my last would be negative 2y times negative 2y, which would be plus 4y squared. So when I combine my like terms, I'll have 49x squared, negative 14x and negative 14xy. Negative 14xy and negative 14xy would be negative 28xy. And then I'll bring down my 4y squared. Example 3. Now here I have a monomial to multiply times a binomial squared. So I'm going to write out my implied multiplication for my binomial squared. So I'll have x times, I'm going to multiply the first, 4x times 4x would be 16x squared. The outside, 4x times 5, would be plus 20x. The inside, 5 times 4x, would be plus 20x. And the last, 5 times 5, would be plus 25. So I have x, and I'm going to combine my middle terms. I'm going to combine my 20x and my 20x, and I'll have 40x plus 25. And now I'll need to multiply my x out in the front. I'm going to multiply this x out in the front times all 3 of them, so that I have x times 16x squared, which would be 16x cubed, and x times 40x, which would be plus 40x squared, and x times 25, which would be plus 25x. Now I want to find the product of conjugate pairs. And again, I'm going to FOIL these. You'll see that something special happens every time you have conjugate pairs. Just happens automatically, and you'll see why as I work it out. So I'll start off, x times x is x squared. When I multiply the outside terms together, the outside, x times y is plus xy. When I multiply the inside terms together, I'll have negative y times x, which is negative xy. And when I multiply the last terms together, negative y times positive y, I'll get negative y squared. And what happens that is special is that every time the outside and the inside terms add up to 0. We have positive xy and negative xy, which adds up to 0. So my final answer would just be x squared minus y squared. And we'll learn later that that is called the difference of two squares. Example 2, I have another conjugate pair, so I'm going to multiply the first, 8x times 8x, which is 64x squared, and then I'm going to multiply the outside terms, 8x times negative 3y would be negative 24xy. Then I'll multiply the inside terms, 3y times 8x would be positive 24xy. It is customary to alphabetize letters if you have different ones, to put them in alphabetical order so they'll look alike every time. And then I'll multiply my last terms together, 3y times negative 3y, and that would give me negative 9y squared. So I have 64x squared, and notice again, negative 24xy and positive 24xy add up to 0, so I'll have 64x squared minus 9y squared. Example 3, 4x to the fourth plus 2, 4x to the fourth minus 2. These are also conjugate pairs. You see the only thing that differs is the sign in the middle. So I'll start off 4x to the fourth times 4x to the fourth. 4 times 4 would be 16, and x to the fourth times x to the fourth. Remember, we add the exponents when we have like bases. We add the exponents. So I have 16x to the 8th. The outside would give me 4x to the fourth times negative 2 would give me negative 8x to the fourth. The inside, 2 times 4x to the fourth, would give me positive 8x to the fourth. And the last terms, positive 2 times negative 2, would give me negative 4. So I have 16x to the 8th, the negative 8x to the fourth, and the positive 8x to the fourth add up to 0. So I'll have 16x to the 8th minus 4. On this one we have a fraction, but don't be alarmed. We do it the exact same way. Starting off with our first terms, 3x times 3x. 3 times 3 gives us 9, and x times x gives us x squared when we add the exponents. Now I have negative 1/3 times 3x, and you'll see the x's cancel so that I'll have negative 1, the 3's cancel so that I'll have negative 1x. And then when I do the inside, I'll have 1/3, positive 1/3 times 3x, and the 3's cancel again and give me plus 1x. And then I have, for the last, I have positive 1/3 times negative 1/3. Let's see, 1/3 times negative 1/3 is going to be negative 1. We multiply the two tops and the two bottoms, so it'd be negative 1/9. So I have negative 1/9. So we have 9x squared, negative 1x, positive 1x, drop out and make 0, minus 1/9. This is Jo Karen Hudson. Thank you, and have a wonderful day.